Hello everybody, Harry from GMAT Ninja here, and welcome to episode 5 in our reading comprehension series for the GMAT and the executive assessment. Now today's episode we're going to take a look at long passages. These are the ones that tempt you into making mistakes by being huge, 4 or 5 paragraphs, and all you think is I need to read quickly to get to the questions, and that's really what causes the problems. First thing I'd say about these passages is please stop rushing. It's going to make such a difference to your scores. Instead, I want you to think about reading at your right pace. Now, that's very personal. It's as quickly as you possibly can, but while maintaining a very high level of accuracy. What we find is that up to a point, people can generally read very well, but as soon as they tip over their tipping point, the accuracy just disappears and they start misreading or not understanding words. And so if that sounds like you, I want you to just dial back on the pace by about 5 or 10% and read at your speed. You might have to experiment to find it, but once you do, these passages get much easier. Now, I have lots of students we could talk about as examples for dealing with these long passages, but today I'm going to tell you quickly about Sarah. Sarah is a very accurate reader, and when we were doing the session, she could easily answer just almost all of the critical reasoning or reading comprehension questions I threw at her. However, her accuracy levels plummeted during her homework precisely because she was trying to go faster. In one of the LSAT sections we were using for her homework, she managed to reduce the time she took compared to last week's homework by about 9 minutes. But her error count jumped from 4 out of 27 to 13 out of 27 questions. And that 9 extra errors for 9 minutes saved just really wasn't worth it for us. Paradoxically, by her trying to go faster, it also meant that it took her longer to answer the questions. Because she didn't understand what had gone on in the passage, she'd get stuck between the final 2 answer choices much more often than if she'd taken her time with the passage, understood exactly what was said, and then just worked carefully and methodically through the problems. So as soon as we steadied her pace and stopped her rushing, her score stabilized. And that's when she started scoring over 40 in the verbal section, which is what she eventually ended up getting onto in the GMAT. Now, as Sarah shows, the difficulty with the long passages comes more from the ticking clock sitting in the back of your head than it does in the passage. That ticking clock makes you want to read faster to get through the passage more quickly, but I really want you to resist that thought. All I want you to do is take your time, read the passage steadily, read it carefully, and think about all those things we've been talking about in this series. What's the author's meaning? What's the purpose? Why are they writing this? What do they want you to tell you? If you go through that process, you'll be much more efficient through the questions and will likely take less time overall than if you'd rushed through the passage and ended up having to fight with each and every question. So today we're going to try and prove that. Now I've got 2 passages for us to look at, both great big long ones, and we're going to try and get through that in the same time as we got through some of the shorter ones in some of the other videos. So I'm going to show you the process you should follow and show you how that doesn't change just because the passage is a long one. All right, so I'll get the first passage of paragraph 1 up on the screen now, and we'll give you a chance to read through it, have a go at sort of breaking it down. I want you to think about what the author's trying to do with his paragraph, why they've written it, and what they want you to take from it. I'll see you back here in about 90 seconds to discuss what's going on. All right, I'll get this one up on the screen and we'll see you back here very soon. Okay, as always with these videos, you need a little more time to think about this one or a bit more time to read it. Now's your chance to pause the video, but I'm going to take it away and apparently make it really small. I don't know how helpful it's going to be to keep this here, but it's what we've done in the other videos, so we'll do it here. In that case, I hope you remember what's in this paragraph, because we're not going to be able to read it. What happened is straight away we get introduced to caffeine. That's what this passage is talking about. And then we get told that these three scientists make some sort of proposal. They make a hypothesis here. And so paragraph 1, really the big thing that we should be taking away from this is that there is a hypothesis, and that hypothesis is that caffeine counters. Now, there's lots of great big words in this passage. We're going to see some bigger ones later on. I don't remember most of these. I'm not really going to worry that too much about what the specific chemicals are, as long as I can differentiate between them. Caffeine counters, I'm just going to call it A, because the chemical started with A. And we're told later on that A inhibits neurotransmitter release. So we've got this hypothesis that caffeine's going to counter whatever this chemical is, and we get told what this chemical does. That's about all we need to take away from this first paragraph. And like I say, long passage. We're not going to rush. We're going to make sure we understand it, but we're going to keep this moving. So I'll get the second paragraph up on the screen right now. I'll get out the way. We'll make this a bit bigger so that you can actually read what it says. And I'll see you back here very soon. Okay, pause the video here if you need a little more time to think about that paragraph. But for now, let's take it away so we can think about what was said here and link that back to paragraph 1. All right, so this paragraph, it's more information about what we've been told in the first one. It's explaining the mechanism. And so in paragraph 2, we get these scientists suggesting that caffeine stops whatever that chemical A was, binding to these two types of receptors, either one, both of them, doesn't really matter. The caffeine stops the adenosine binding to receptors, and this enables the neurons fire more easily because of that. So really, paragraph 2 gives us the mechanism for what paragraph 1 told us about. We introduced the caffeine. We said that caffeine stops this chemical from working, and this is how and why it does that. So we're beginning to get a bit of a link through these paragraphs. All right, long passage. As I said, we need to keep this moving. We're not rushing, but we're just going to keep moving. Paragraph 3 is coming up for you in just a second. I'll see you back here in about 90 seconds' time. All right, this is a bit of a longer paragraph, so if you need a bit more time to have a think about this one, now's your chance to pause the video, but as you can see, we shrunk it down. We're going to take a look at what this one says. All right, so slight change of direction here. First two paragraphs talking about how caffeine blocks the behavior of this chemical A. We've got another chemical introduced here. Another great big long name, not going to try and pronounce it, certainly not a scientist myself. P. That's all I'm going to refer to it as P. Now, what we get in this paragraph is the description of some sort of conventional belief. And that's that caffeine blocks this new chemical. But if you don't get sucked into the details too much, if you don't get blinded by all the facts, all the science going on here, and you just keep reading, what's the author trying to tell you? Well, what we actually find out in the end of this is that the scientists suggest this is not possible. Now, they give us two reasons for this, that the level of caffeine that you would need, or the amount of caffeine you'd need to take in order to block this chemical P, is just too high. It's far higher than you would need to be a stimulant. Second reason is that everything else that blocks this chemical, they're not stimulants. So why would caffeine, which is a stimulant, behave in this way? But really, the big things to take out here is we have some sort of conventional belief about the behavior of caffeine, and the scientists suggest that this is not possible. All right, I'll get the fourth paragraph up on the screen just now, and we'll give you a chance to have a read of this one, and I'll see you back here very soon. Okay, paragraph 4 out of 5. We've got one more to go after this one. Let's have a think about what was said here. So by the looks of it, paragraph 3 was a bit of an interlude. It's something different. Paragraph 1 and 2 were all about why or how caffeine blocks that chemical A. Paragraph 3 took us to talk about the new chemical P. Now we're back to A again. But this time, the scientists aren't really talking about caffeine. They're supporting their argument. So the scientists, they support this hypothesis they made back in paragraph 1 by showing that caffeine-like chemicals bind to receptors, and that was the method shown in paragraph 2. So really, we're showing that this mechanism that the scientists discuss in paragraph 2, other chemicals do it as well. And we get that example at the end that whatever, I'm going to call it T, because the great big long chemical that is the main stimulant in tea does or has a very similar effect to what caffeine does, and at least that's what the passage tells us. All right, we got one more paragraph. We're nearly there. I'll get this one up on the screen for the last time. I'll see you back here in about 90 seconds. All right, for the final time for this passage, if you need a little more time to think about what's just been said, now's your chance to pause the video. But for now, let's take a look at what was said so that we can get onto the questions. All right, so start of this paragraph, we get the notion that there's some potential exception here. Now, I'm really not going to try and pronounce the name of this chemical, but IBMX, I think they put it in the passage. But that's introduced as a potential exception to the way that the caffeine works. So that we've got all these similar chemicals that were introduced in paragraph 4 that act like caffeine, and now we get one that is a potential exception to the theory that might damage the theory. But the whole point of paragraph 5 is the scientists come in and explain away this exception. They say why this chemical doesn't affect their theory. So the scientists explain away the exceptions to that hypothesis they made back in paragraph 1, and they go on to suggest that the stimulation effect is influenced by the caffeine concentration. So the concentration of caffeine in your system will affect the stimulation effect. All right, so huge, great big long passage there. As you said, 5 paragraphs. That's longer than almost anything you're likely to see on the GMAT. But I hope you've been able to follow the thread as it's worked through there. Really what we're looking at here, as we said right at the stop, there's a hypothesis that caffeine counters the effect of the adenosine. And what we're looking at here is how does caffeine have its stimulatory effect? That hypothesis that we started with, that's what the scientists are saying is working. Paragraph 2 gives us the mechanism. Paragraph 3 saying, well, the conventional belief was that caffeine had a stimulating effect by blocking this chemical P, but that's not possible. Paragraph 4 came in and said that, well, caffeine acts like many other chemicals. Look at tea. We've got the same chemical in tea. And then paragraph 5 comes in and says, yeah, you think you've got an exception, but this is why that exception doesn't really count. So we're all building around this idea that the way that caffeine has its stimulation effect is that it counters the effect of this chemical that we called A right back at the beginning. Now, if you've taken the time, if you've understood the passage here, what I'm hoping is we'll find is that that'll make the questions a little bit easier when we get to them. So I'm going to get the first question up on the screen there. It will be a bit bigger in a second, and I'll give you about a minute's time to take a look at it, and we'll see you back here to go through this problem in just a second. Okay, now's your chance to pause things if you need a little more time to think about this one. And then I'm going to move that along, make the question a bit bigger so that we can still see it as we're going through this. And let's talk our way through this one. All right, so talking about the primary purpose of the passage, as I said, huge, great, big, long thing. We've done a lot of reading here, so hopefully this one goes fairly smoothly. Let's see what happens when we get into the answer choices. So A tells us the primary purpose of the passage is to discuss a plan for the investigation of a phenomenon that's not yet fully understood. So we could say that the phenomenon is not really fully understood yet. We're still looking at how caffeine has a stimulatory effect. But at no point in this passage is there a discussion of a plan. We're talking about the results of experiments that have already happened. So A is not going to be our answer to question 1. All right, looking at B, so that B tells us the primary purpose of the passage is to present 2 explanations of phenomenon and reconcile the differences between them. Now, you could argue that they do present 2 explanations of phenomenon. Remember in paragraph 3, we talked about this conventional belief. The rest of the passage was talking about how caffeine counters the behavior of this chemical A, whereas paragraph 3 was talking about caffeine countering the behavior of P. So you could argue that we have summarized 2 theories, but presented 2 explanations of phenomenon. But B says that it then goes on to say that it reconciles the difference between them, and it definitely doesn't do that. The end of paragraph 3 kind of goes, this This is not possible. And the rest of the passage is saying why that their initial hypothesis that caffeine counters the behavior of this chemical A, why that is the way to do it. So because we're not reconciling the difference between those two explanations, B can't be the answer here. All right, C tells us the primary purpose of the passage is to summarize two theories. We've already said two theories. Yeah, you could make that argument there. And then suggest a third theory that overcomes the problems encountered in the first two. Well, we don't ever get a third theory. Yeah, we get that conventional belief in paragraph 3. We get the same theory running through the rest of it. So at most, you could argue there's two theories in there. There isn't a third one that's introduced, so it's not going to be C. All right, D tells us that the primary purpose is to describe an alternative hypothesis and provide evidence and arguments that support it. Now, you might not like the way that's phrased, the alternative hypothesis, to begin with, but just remember back, we talked about some long-standing belief here. The conventional belief is that caffeine counters or blocks P. But the whole point of the passage is that no, caffeine doesn't block P. It counters the behavior of A, whatever these chemicals are. So that initial hypothesis we got right at the start, that is the alternative hypothesis that D's talking about. And then the rest of the passage is providing evidence and arguments that support it in different ways. So yeah, we get the mechanism, we get the alternative method isn't happening, we get the similar chemicals are behaving in a similar way, and we get that the potential exception doesn't really count. So D's looking good. But let's just check E just to be sure. And E tells us that the primary purpose of the passage is to challenge the validity of a theory by exposing the inconsistencies and contradictions in it. Now, again, you could begin to think about that third paragraph and say that the passage does challenge the validity of that theory. But even then, it doesn't do that by exposing the inconsistencies and contradictions within that theory. It just says it can't work. And also, is that really the primary purpose of the passage? That whole part was just contained within one paragraph, and we'd be ignoring all the rest of it. So for that reason, E's not going to be our answer. D's the only one we're left with, and D's going to be our best option here. All right, so there's one question, the primary purpose of the passage. We're going to get into other types of questions as we go in. Next one's going to ask you to focus on or makes you think you're going to be focusing on the details, but really it's all about an understanding of what the passage was describing. Again, we've got a lot of information here. I don't want to get sucked into the details. I want to keep thinking about the author's purpose and what they're trying to do. So I'll get the next question up on the screen. Like before, we'll give you about a minute to have a think about this one, and I'll see you back here to go through it very soon. All right, now's the chance to pause it if you need a little more time to think about this one, but I'm going to make that question a bit bigger so that we can see it, and let's have a look through this one. All right, so this is a sort of question that's going to be really tempting to go back and do a bit more reading because it feels like a really detail-orientated question. It feels like you really need to know the difference between these chemicals. But in a passage like this, an enormous, great big passage, loads of stuff going on, doing that is probably going to take a fair amount of time. So what we're going to do is we're going to give this question a go, see what we can do using our big picture understanding of what's been said. And if we need to, maybe we can take another look at the passage, but hopefully we're going to be able to eliminate a few answer choices before we do so. So the question is about, so we've got caffeine has an ability to bind to these two types of receptors. And the question asks us that it can be at least partially attributed to which one of the following. So A tells us we can attribute that ability to the chemical relationship between caffeine and this chemical P. Now, if you remember what was said in the passage, this binding to the receptors was discussed in paragraph 2. It's the mechanism by which caffeine counters the behavior of A. This chemical P, this other one, doesn't come in until paragraph 3, and that's when we're discussing this conventional belief and why this conventional belief is not possible. There was nothing about caffeine being similar to this chemical P in the first place. And there was also nothing about that similarity, even if there was one, being the reason that caffeine can bind to those receptors, because the binding to receptors was in a completely different part of the passage. So for that reason, or for those reasons, I'm going to cross A out. Now, B tells us that we could attribute this ability to bind to these receptors to the structural relationship between caffeine and this chemical A. Now, this is looking better, because this is really what the passage is about. Paragraph 1 told us that caffeine was going to counter the behavior of A. Paragraph 2 told us it was going to do that by binding to these receptors. And it could bind to these receptors because the two chemicals, caffeine and A, were very similar. They were going to both be able to bind to receptors. It was just caffeine was going to swoop in there first and block A from binding itself. So B's looking pretty good. Let's leave that for now, but we'll check the other three just to be sure. Now, C tells us that we can attribute caffeine's ability to bind to these receptors to the structural similarity between caffeine and the neurotransmitters. Now, the whole point of the passage was that caffeine is going to stimulate behavior by binding to these receptors instead of this chemical A, and that would stop A from blocking the release of the neurotransmitters. So there's nothing in the passage about any similarity between caffeine and the neurotransmitters. It's just that caffeine allows these neurotransmitters to be released by binding to these receptors and stopping A from doing what A wants to do. So because there's nothing about the structural similarity between caffeine and neurotransmitters, and because there's no indication that that is the reason why caffeine can bind to these receptors, let's cross C out, then keep going and take a look at D. Right, D tells us that we can attribute this ability to bind to receptors to the ability of caffeine to stimulate behavior. So we've got a bit of a cause and effect thing going on here. After A binds to the receptors, that allows the neurotransmitters to be released, which does stimulate the behavior. So it's not that the ability of caffeine to stimulate the behavior is the reason why they can bind to the receptors. It's the other way around. Because they can bind to the receptors, that's why caffeine can stimulate behavior. So cause and effect is completely the wrong way around in D, so we can cross that out. And finally, E would tell us that caffeine's ability to bind to these receptors can be at least partially attributed to the natural occurrence of caffeine and adenosine in the brain. Now, I've got to admit, I don't remember seeing anything about whether caffeine and adenosine were naturally occurring in the brain in the passage, but that doesn't necessarily mean they're not the answer. I think the point here is that there was nothing in that second paragraph when we were talking about what was going on with the binding to the receptors, that the reason why they could bind to the receptors was that these things naturally occurred in the brain. There was an indication, or at least they left open the suggestion, that synthetic chemicals could bind to the receptors. So it's not the natural occurrence that allows them to bind to these receptors. And also it's more that the structural similarity, just because these things are occurring naturally in the brain doesn't make caffeine able to bind to the receptors. And so E is not going to be our answer. And that leaves us with B as our best choice here. All right, so like I said, question looks like it's all about the details. But if you remember what the passage was saying, how it was structured, how the authors were threading that argument, we can actually get through this without needing to go back to look at the passage and really zoom in on the details. And that's one way you can save time in these questions. At least give the question a go before you dive back in studying for the details you think you might need to answer the question. All right, we've got one more question on this passage. I'll get the next one up on the screen now. We'll give you another minute to take a look at it, and I'll see you back here to discuss it soon. All right, final time for this passage. If you need a little more time to think about this question, pause the video now. But there we go, I'll make it a little bit bigger so that we can take a closer look at this one. All right, so we've given you the question there, and we've also got the quote that this question was talking about up at the top of that top of that inset there. And what we're really doing with this one is saying, so the author quotes Snyder et al., as we put up here. Why did they do it? That's what we're looking for here. What is the intention? What's the author's purpose behind doing this thing? So let's take a look at the answer choices and see what we can make of them. So does the author quote Snyder et al. In order to reveal some of the assumptions underlying their theory? Well, there are no assumptions that they present in this. We get a description of the results and that's about it, or a description maybe of the implications of the result, but no more than that. They certainly don't reveal any of the assumptions underlying their theory in this quotation. So it would be very difficult to say that the authors quote these scientists in order to reveal their assumptions. So let's cross A out. Now, B tells us that the author quotes these people in order to summarize a major finding of their experiments. Now, this one looks good. Yeah, we get a major finding here. The ability of the compounds to compete at the receptors correlates with their ability to stimulate locomotion in the mouse. There's a major result of their major finding of their experiment. And so this, B is looking good. Let's keep that for now. Let's keep this going. So C tells us that the author quotes these people in order to point out that their experiments were limited to the mouse. And in some ways, they're almost doing the complete opposite here, that yes, these experiments were in mice, but the whole point is, in general, the ability of the compounds to compete at the receptors correlates with the ability to simulate locomotion. And then we get this bit in the mouse. So we're talking about the major finding that they found. There's nothing here that is saying that they are limiting the experiments to the mouse, or at least that's not the point of the quotation. That the whole point is not that the author is doing this most probably in order to point out that their findings were limited just to mice. So I'm going to cross C out, and we'll take a look at D. And D tells us that this quote was presented most probably in order to indicate that their experiments resulted only in general correlations. Now, again, you might be able to argue that their experiment is only giving general correlations at this stage, but is that the reason why the author is put in there? Well, again, if you looked at the bigger context, if we think about what was said here, no, the author isn't saying that, or the author isn't quoting this to indicate their experiments only resulted in general correlations. It's just more, here are the results. Now, the results indicate a general correlation here. So we're not using the quote to limit the experiments to the general correlations. So D is not going to be our answer. And finally, E tells us that the reason the author quotes Snyder and al. Is most probably in order to refute the objections made by supporters of the older theory. And the older theory was this caffeine blocking the production of this chemical P. Now, if you remember paragraph 3, we said that operated kind of as a standalone. It was doing something very different to 1, 2, 4, 5. It was still part of the overall argument, but it wasn't linked as closely as this. The author is not presenting this quotation in order to refute the objections made by the supporters of this older theory. He's telling us about the experiments that went on in paragraph 4. And so we can cross E out, and that leaves us with B as our answer here. So again, last two questions. I hope you've seen that while they are talking about small bits of the passage, at least, you can get through them without zooming in on the details. As long as you get that good understanding of the big picture back at the beginning, we've been able to answer these questions without really needing to return to the passage. And that's the point of this video, that with these long passages, if you take the time up front, if you really read them carefully, if you get a good enough understanding of what the passage says early on, you can hopefully make up for that time when you get into the questions, not by rushing, but by efficiently working your way through them because you know what the passage said. All right, that's the end of the first passage. I've got one more to take a look at. We'll go back through this one. I think we've got 4 paragraphs in this one. We'll go through each of them turn by turn. We'll have to be efficient, but we're not going to rush. Have a look at this one, this first paragraph, and have a think about what's the author trying to tell you, how are they trying to do it, and just like we've done here, we'll come back in about 90 seconds to take a closer look. All right, good luck with this one. I'll see you back here soon. Okay, pause here if you want a bit more time to think about this one. But let's take a closer look at what paragraph 1 is telling us in this passage. All right, again, another, I don't know why we've chosen 2 science passages for this one. They're just both long ones. But again, another one where there's quite a lot of difficult terminology. I'm not going to worry too much about how these things are pronounced. I'm not even going to worry about the full names of them, as long as I can identify them and use them in the passage. So I would say in this passage that paragraph 1, overall, we introduce this new type of regulatory molecule. Just called O. Again, I know they've got a longer name. I'm not going to be able to pronounce that the whole way through this video. I'm not even going to remember it. So I'm just going to call them O and we're going to go with it. And that's in addition to 5 hormones. So we've got these 5 ones that we know about. We've introduced this new class of chemicals. Again, call them O for now for the sake of this video. And these are the chemicals that help the plants differentiate what type of cell they should be. That was the whole point of this first paragraph. We'll get the second one up on the screen just now. Again, we'll give you another 90 seconds or so to have a think about this one. We'll see you back here to go through this one very soon. Okay, pause it there if you want a little more time to think about that paragraph. But let's keep this moving. Let's go through this one. So that last paragraph, we introduced this new type of chemicals and we said, okay, we had 5 hormones that we knew about, but there's this new type, starts with O, that we're going to talk about we're introduced in this passage. Now, this second paragraph begins to separate those 2 things out. It shows us the difference between them. So what we could say about this passage, this paragraph, is that the author uses, and I'll call this chemical A, again, I'm not going to try and pronounce the whole way through, don't need to remember exactly what it was called, but as long as I can identify it, uses this chemical A to show that the old hormones, the 5 hormones, they are general, and these new, whatever they were, the O's, they are specific. This paragraph is about separating the new chemicals from the old ones. The hormones are general, these new chemicals starting with O, they're specific, and we use one of the hormones, this one that starts with an A, and the behaviors that A makes the plants take part in to differentiate between the 2 of them. Okay, so we've got a separation between these 2 things, and that's the big thing that's going on in this second paragraph. All right, we'll keep this moving. We've got 4 paragraphs to go through, so paragraph 3 of 4. We'll get that one up on the screen, and we'll see you back here soon. Okay, pause here if you want some more time to think about paragraph 3, but let's keep this moving and keep going through these. So paragraph 3 begins to talk more about the 5 hormones that we know and we love, that they've been around for a while, they've been studied a long time, and they're analogous to some certain animal hormones. And that's really where we're going with this, that the generality, the generalness of these 5 hormones, the fact that they do multiple different jobs. So the generality of the 5 hormones is similar to some animal hormones. And the way that we get this cascade of chemicals affecting different parts of the body, that introduced this hierarchy of hormones. That's introduced towards the end of the passage. And the idea that one hormone can stimulate another hormone, which will make another thing that will do various jobs, and it sort of works its way down that system. We get this idea of a hierarchy of hormones, and that's the end of paragraph 3 here. All right, we got one more paragraph to go. We'll get this one up on the screen. As you can see, it's a short one. We'll give you about a minute here, and we'll see you back here very soon. Okay, for the final time on this passage, if you need a bit more time to think about this paragraph, now's your chance to pause it. But let's take a look at this so we can bring this whole thing together. All right, so final paragraph here. We had that analogy brought in the last paragraph about this. The plant hormones are similar to the animal hormones, and we get this hierarchy of hormones that was introduced. Now, this final paragraph goes on to say that it suggests that the hierarchy exists in plants. Now, then we get this bit telling us that these chemicals, these whatever they are released by enzymes. And the suggestion is that the hormones will sit at the top of this hierarchy, and they will activate the enzymes which decide which of those chemical O's, whichever one it is, to release. So the suggestion is that up at the top of this hierarchy, we've got the hormones, and one of them will be produced, and that will determine which enzymes are produced, and the enzymes will determine which one of these chemical O's are released, and that will work its way through the plant and will determine how the plant is going to differentiate their cells, as we discussed back in the first paragraph. So we've got these new chemicals introduced. They are very specific, as we talked about in the second paragraph. The 5 hormones that we know about, very general. They are similar to the animal hormones, or at least analogous. That's what paragraph 3 told us. We got this introduction of this hierarchy of hormones, and that we said that the 5 that we knew about, they sat at the top. The release of one of those would stimulate the release of some enzymes, and those enzymes would release some of these new chemicals down at the bottom. And that's where we go with this passage. Now, again, lots of details here. And as you can see, I haven't got sucked into going into the depths of the science. It's a long passage. I've just kept reading. I've made sure I understand the big picture. And hopefully we're going to be able to use that to answer some of these questions. All right, we've got 3 more questions for you here. I'll get the first one up on the screen in just a second. We'll give you about a minute to take a look at this, and we'll see you back here very soon. Okay, pause here if you want a little more time to think about that one, but I'll make the question a bit bigger so that we can see it, and let's go talk our way through this one. So this question is about why the author discusses these animal hormones. Now, as you remember, that's a big part, paragraph 3. We sort of say that the 5 hormones that we know about, they're very similar to animal hormones, and then we discuss how animal hormones work by working in that hierarchy of hormones, and that introduces this concept of hierarchy of hormones that we then go try and apply to plants in paragraph 4. So we're looking for why the author discusses these animal hormones, and A would tell us that the reason why the author discusses them is to introduce the idea of a hierarchy of hormones. Straight away, this is looking pretty good. It's what the author does. It's certainly almost the entire part of that paragraph 3, except for the introduction, which is just where he sort of talks about how the plant hormones are very similar to the animal hormones. So I'm going to keep A for now. If there is a better option later, then maybe we'll come back to this. But for now, that's looking pretty good. All right, B tells us that the author discusses the animal hormones in order to explain the effects that auxin has on plant cells. Well, that was really what we were talking about in paragraph 2. That was this chemical A here. Now, this chemical A, that's a plant cell. And to explain the effects that this chemical A has on plant cells, we didn't talk about animal hormones in order to explain that. We didn't really even explain it. We just listed them out back in paragraph 2. So the author doesn't discuss the animal hormones in order to explain the effect that this chemical has on the plant cells. So I'm going to cross B out. All right, C tells us the author discusses these animal hormones in order to contrast the functioning of plant hormones and animal hormones. He doesn't really contrast them. He says that they act in similar ways and uses the animal hormones, or uses the description of the animal hormones as an analogy of how these 5 hormones might work. So there's no contrast to the functioning of them, there's definitely no contrast to the functioning of them because they function in different ways. They're doing different things. One's in animals, one's in plants. We were just saying that there is a hierarchy of the 2 of them. So the author doesn't discuss the animal hormones primarily in order to suggest that, or to contrast the functioning of these hormones, so we can cross C out. Now, D says that the author primarily discusses these animal hormones in order to illustrate the ways in which particular hormones affect animals. Now, he does tell us a little bit about how the hormones affect the animals. He discusses how this hierarchy works. One hormone will work on one organ, which will stimulate the production of another hormone, which will work its way down. That's the whole point of the hierarchy there. But is the primary purpose of discussing these hormones to illustrate the way that happens? And I'd say no, it's just that is the hierarchy. We need that in order to get to the idea that plants have that hierarchy too, which is what this passage is really about. So while that paragraph might illustrate a little bit about the way in which particular hormones affect animals, it's not the primary purpose of that discussion. And so we can cross D out. Right, E tells us that the author discusses these hormones primarily in order to explain the distinction between hormones and regulatory molecules. And yeah, that's not really what's going on here. The whole point of that paragraph was just the hierarchy of hormones that you get in animals. And in that paragraph, it just goes hormone to hormone to hormone to hormone. We don't really get this discussion about regulatory molecules until we're back talking about the plants and their hierarchy of hormones. That's not the discussion about animal hormones. So for that reason, we can cross A out. And while A, and the reason I said when we looked at A that I was like, let's come back to it if it's the best answer, is because A probably doesn't match the ideal answer that I've got in my head. But that doesn't matter. That's not what we're doing here. And if you begin to go down that path and say, it's not what I was looking for, so I'm going to cross it out, you're likely to head into a lot of danger here. So certainly when you're early on in the question, it pays to be a little bit more conservative, to say, okay, it looks good. It might not match the exact answer that I have in my head, but it does the job. Better to leave it, check the others. As you found, we could cross out B, C, D, and E, and A. So the author discusses these animal hormones primarily in order to introduce the idea of a hierarchy. And that's where we're going with this question. That is, A is the answer to this one. All right, I will get the next question up on the screen. As before, we'll give you about a minute to take a look at this one, and we'll see you back here soon. All right, pause here if you want a bit more time to think about this one. But let me change that so we've got a bigger question that we can actually see and talk about here. All right, so this is another question. Like question 2 and 3 on the previous passage, this is another one that feels like a detailed question. But let's take a closer look and see if we can get through it using our understanding of the bigger picture here. So we're asked for which of the following best describes a function performed by these chemicals. Oh, I'm not going to try and read that. I'll butcher it and it'll be horrible. So these chemicals, which of the following is a function that these chemicals could perform? Now, again, let's just have a think about the passage before we jump into this one. The point of the passage, the introduction or the opening paragraph told us that this was about how plant cells differentiate from each other. It was the long-term development of these cells and how do we know which one's going to be a root cell, which one's going to be a leaf cell. So when we look at A and say that these chemicals could regulate the daily functioning of a plant cell, that doesn't sound very good, because this is not about the day-to-day functioning of the plant. That was at no point was that discussed in the passage. So at that point, we could say that A is not going to be our answer here, because it's just not what the passage was discussing. There's no mention that these chemicals would regulate the daily functioning of the plant cells. All right, so B tells us that these chemicals would interact with one another to produce different chemicals. Now, if you remember way down at the bottom, we talked about that hierarchy of plant hormones. The hormones were going to release some chemicals and they were going to create the enzymes. The enzymes were going to release these O chemicals and they were going to go and do something. So that the way we describe the hierarchy in the plants, these chemicals that we're talking about here, they're at the bottom of the hierarchy. There's no indication that they interact with each other. It's just that they are produced and they go and do their job. So for that reason, B is not going to be our answer here. These chemicals do not interact with each other to create other chemicals, or at least that's not what the passage told us. Right, C tells us that these chemicals are releasing specific chemical messengers from a plant's cell walls. Now, that might sound good, but if you think about, again, what that hierarchy told us at the bottom, these chemicals, starting with an O, these chemicals are the things that are released from the cell walls. They are not releasing the chemicals, they are the things that are released. And so for that reason, the releasing of the chemicals is not the job of these O chemicals, whatever that name is. They are the things that are released. And so C is not right, and we can cross that one out. Again, be very careful with the wording there. That sounds good, but these chemicals do not release other chemicals. They are the things that are released. All right, D tells us that the O's produce the hormones that cause plant cells to differentiate to perform different functions. Now, again, go back to that bottom paragraph with the order the hierarchy was in. The hormones produce the enzymes which produce these O chemicals. So these O chemicals aren't producing the hormones, because now that we're back to the top of that hierarchy and the hormones are at the top of that hierarchy, these O chemicals weren't there. So D gets our order all in a muddle, and we can cross that one out. And okay, we're left with one answer choice. Hopefully E is going to be our answer, but let's go check it out. So one of the jobs performed by the O chemicals could be influencing the development of a plant cells by controlling the expressions of the cell's genes. Now, this sounds good. And go back to that first paragraph. What was this talking about? It was about how does a plant cell know whether to be a root cell or a leaf cell or a tree trunk cell or whatever. And the hormones will produce the enzymes, will produce these O chemicals, and the O chemicals will disappear off, and they are the ones that will influence the plant cells and how the gene expression works there. So for that reason, and we've crossed the others out. So for all those reasons, E is going to be our answer to this question. And again, a question that looks really like a detailed question that we might feel like we want to zoom in and return to the passage for. But if you think about the big picture, we can make it a long way, hopefully all the way in this question, without needing to do that extra work, without getting obsessed by the details. Focus on the big picture, the author's purpose, and that will help you get a long way in lots of these questions. All right, we've got one more question for you. Final time for today. I will get this question up on the screen. I'll give you about another minute to take a look at it, and I'll see you back here soon. All right, for the final time today, if you need a little more time to think about this one, now's your chance to pause the video, but I'm going to make the question a bit bigger so we can talk about it, and let's take a look at this one. All right, so this question asks us to compare the two hierarchies, really. We talk about the hypothalamic hormones in the animals and say, well, where does that link to in the plant hierarchy? Now, full disclosure, I actually went back to the passage when I was thinking about this question. I'm just taking a look at it now before we go through this answer, because in the plant hierarchy, we know it went the hormones, they create the enzymes, they went to work on the plant cell wall, which made these O chemicals, which disappeared off and affected other plant genes. So in the hierarchy in plants, and very clearly I've got various different things, different names. Whereas my understanding of the animal hierarchy was we had some organ that created a hormone, that affected another organ to make another hormone, another organ to make another hormone, and that worked on another organ. So I wasn't really sure where it fit. Quick look back at the passage, the hypothalamus was the first organ. It was right at the start. So we're right at the top of the animal hierarchy. And we're saying, where does that link to in the animal hierarchy? Sorry, the plant hierarchy. So A tells us that, or A suggests that the hypothalamic hormones are similar to the plant cell walls. Now, the plant cell walls are quite a way down in the plant hierarchy. Remember, the hormones made the enzymes that affected the plant cell walls. Those released those O chemicals, whereas the hypothalamus hormones are right up at the top of the animal ones. So A is not going to be our answer. Now, B, the complement of the genes in each plant cell. Genes in the plant cell, they're way down at the bottom of the plant hierarchy. The genes in the plant cell are being affected by the O chemicals. They're being made from the plant cell wall. They're being affected by the enzymes. They're being affected by the hormones right at the top of the hierarchy. As I said, the hypothalamus is right up at the top. The plant genes, the genes in each plant cell, they're way down the bottom. So that's going to cross out B. And that's going to be a similar thing for C. So a subset of the plant cell gene component. Again, the plant's genes are right down at the bottom of the plant hierarchy. The hypothalamus hormones are right at the top. So C goes. Now D, the 5 major hormones, they were right at the top of the plant hierarchy. This one's looking good. Hypothalamus is top of the animal one. 5 major hormones are top of the plant one. They're analogous in position in the two hierarchies. So let's leave D for now. Now E, our O chemicals. What we've been talking about in this whole passage. As we just said, in the plant hierarchy, they're kind of 4 or 5 steps down. Hormones, enzymes, plant cell wall, release these O chemicals. They go off and affect the genes in the plant cell. So we're a step or 2 above the bottom, maybe depending on how you deal with the hierarchy. Whereas in animals, hypothalamus right at the top. As we said, those 5 major hormones right at the top. E is not going to be our answer, and we can take D for this one. All right, so as I said, I needed a quick look back at the passage here, but that's okay. With these long passages, as long as you take the time to understand them up at the beginning, and as I said right at the start of the video, please, 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 please don't rush. Find your reading pace. It's as quickly as possible, but quickly as possible while being accurate. Once your accuracy disappears off a cliff, you're going too fast. Dial it back, read as accurately as you can, understand the passage, and then, as I hope you've seen, we're able to get through these questions relatively efficiently. You'll make up the time on the questions if you understand the passage well. Long passages are no more difficult than other passages. They're just longer. And so follow the same path, everything that we've been talking about throughout the series. And as you've seen, you get that good understanding of the overall passage, and you're going to be okay when you get to the questions. All right. I hope that's been helpful. That's all I've got time for you for today. Have a great day, everybody, and we'll hopefully see you back here for another one of our videos soon.